one of the more important things you want to be able to do, given all of the information, okay, given initial concentrations or activities and the value of the equilibrium constant, is how far will the reaction go? Okay, that's uh, that's the most common question you'll be trying to answer with problems pertaining to equilibrium. How far will it go? And that means what are the values of the concentrations on equilibrium? Okay, so the generic procedure is set up an ice table, list the initial concentration, uh, tabulate the changes in terms of variable extent of reaction x, and then express the equilibrium concentration in terms of that variable x, right? Compare q and versus keq to determine whether it's going to go forward or reverse. Okay, so we're going to let x be the extent of reaction, and solve for x, knowing that q must be equal to keq at equilibrium. That's the generic procedure. And usually, in this last step right here, when we solve for x, we try to look for a way to simplify our calculations, because more often than not, we're going to get uh, polynomials, quadratic equations. So if we can find a way to get an approximation, that would be good. Okay, and so you need to look out for very large KEQs or very small KEQs, because if you have a very large KEQ, what does that mean? You can assume everything. You can imagine everything going all the way to the products except for the excess reactants, and then you have a trace amounts of limiting reactant left. Okay. Or if it's very small, then you can imagine the reaction shifting all the way to the reactant side. Okay, so that makes things a lot simpler. And in fact, for most of your exam questions, that's probably what you're going to get, because you're not going to be expected to solve a cubic equation on a 1-hour test, along with other problems. Okay,